Okay, so we're going to go over the 13.1 and 13.2 FIP quiz. I'll then take a picture and put it up on PBWorks. Number 1, sound waves propagate in all directions from a source is really the best answer. Some of you wrote spheres. That's acceptable. Circles is not. Forward is not.
Outward.
Yeah, outward is questionable. All directions is your best answer. Doppler effect causes sound waves, and these were some interesting answers, from a moving sound source, not light source, sound source, my darlings, not red-blue shift, from a moving sound source to be compressed in front of the source, and therefore sound higher in pitch, and to be extended or pulled out or drawn out behind a moving sound source, and therefore sound lower in pitch.
See, I have higher and lower, right?
This is number 3 on the FIP. What's the intensity of sound waves from an amp at a distance of 0.5 meters if power output is 1.75 watts? So we know that I equals P over 4R, or 4 pi R squared. And for this particular problem, that gives us... Okay, so for this particular problem, that gives us I equal to 1.75 watts over 4 pi 0.5 meters squared, and I changed color, yes. And so that gives us an answer of 0.557042301 watts per meter squared. Whoever wrote this stupid problem only gave you 1 sig fig, so I is equal to 0.6 watts per meter squared. Okay, fantastic. All right, so now the second part of that question is, by what factor does the intensity decrease if the distance from the amp is doubled? Because the radius is squared, it's by a factor of 4. That was also worth a point. So if you failed to address that part of the question, then, okay. Yeah, if you failed to, and you could have worked that out for yourself, and I recommend that if you tend to get screwed up on that stuff, work it out for yourself.
Did you say the second part of the answer?
Second part of the answer is by a factor of 4. So actually, if you look at these arithmetically, what's 0.5 squared? Or it's 0.25. What's 0.25 times 4? 1. So here you're dividing the power by pi. Here, 1 squared is 1. You're dividing it by 4 pi. Decreases by a factor of 4. So, yeah, and you can do the little algebra trick there. So, decreases by 4, factor of 4. Okay, so for for number 4, how much power is radiated from a band whose intensity is 2.9 times 10 to the negative 4th watts per meter squared at a distance of 5.6 meters. So we have to solve for power. I 4 pi r squared equals P. You don't actually have to use all those parentheses. It's just a habit of mine. So what this gives you is 0.11428361 watts is their power output. And that's got 2 sig figs, so 0.11 watts equals power. Okay, pretty easy algebra, just people made silly mistakes or didn't understand the distance thing. All right, now allowing that maybe I did make a mistake, but I don't think I did. This is the raw answer you get. Now, this would be 1, 2, 3, 4, 5, 6. 9.861 times 10 to the negative 6. Well, we only have 1 sig fig here.
Did anyone
This
get
is-
that wrong answer?
I didn't get that wrong answer.
I'll put this on the recording too. Teacher error, there is one more 0.
What does that move it to?
Hold on. Okay, so now this would be 1, 2, 3, 4, 5, 6, 7. Let's round this in raw form. 0.000001. 1, 2, 3, 4, 5, 6. So 1 times 10 to the negative 6.
60 dB.
So, okay.
Got a perfect paper. Perfect paper.
Okay, so if you look at the decibel chart on your paper, that corresponds to 60 dB, 60 decibels.
That means I got a
And
7
but this is the place to be careful. Usually a lot of people miss this because they look at this and go, oh, 10 to the negative 7th. And they correspond that on the chart, but you have to get it, you have to get it rounded first.
So that
So
means
Do I get a bonus point?
okay, so for number 6 on the fifth, the graph was a little bit tricky. I'll have to give you a clearer one. It should have been threshold of pain, but some of you probably saw area of sound. So I'll give you a clearer image for the test. All right, that's it for the FIP, and see you Monday.